Hi, I'm Ed Sobey from Kids Invent. We're here starting our flying toy activities, and the skimmer is the first one. This is a very simple flying toy that uses rings of paper, just standard office paper, and a straw. But once kids get started, they'll have all sorts of other design ideas that they're free to try. Unlike most of the other activities where we don't want you to show them an initial design, this is one where you probably need to. So cutting the paper for these two rings, I like to cut the first strip about 1/2 inch along the width of the paper, and then the second strip just a little bit wider along the length of the paper. The larger ring, in this case, you can see I've taped it into two rings and taped it to a straw. The larger ring goes in the rear. If I throw it the other way, it will self-correct in flight. The larger drag will go slower and it will change and off it goes. This is an activity in which being a little bit meticulous is very helpful. Those two rings have to be parallel. If they're not parallel, it's not going to fly far. But you don't have to tell them that. They'll find out in plenty of time. One thing that is helpful to tell them, however, is with this and with all the other flying toys made of paper, you'll notice that many of them just stop in midair and fall. That indicates to you they need more mass. Add a paper clip or add 2 paper clips. Anything you make to fly out of paper is really happier with a paper clip right there. Now, once they have this model, and we're trying to see if they can get it across the Pacific Ocean to Japan, which you conveniently have labeled on the floor, or you set up distance measurements so they can see how far they go. Once they have that set up, they can try changing those rings into non-rings, or they can change them into triangles, or they can do any number of other options. They can use 2 straws, they can try 3 or 4 rings. They can be as creative as they would like to be. All we need them to do is record their success and failures each time, including a measurement and what they did, so we have a scientific process. At the end, we can look at the models that have gone especially far versus those that have not gone especially far, and the students can suggest why one was more successful than another. At the very end, as they're leaving, suggest to them this is an activity that they can do at home with just a straw, some tape, and paper, and challenge them to come back tomorrow with one that goes really, really far. Have fun.